All right, guys, good morning. Let's look at the idea of assessing normality. In other words, the question is, is the data close to normal? Because remember, if we have to figure out if it's normal or not, if it's normal, we can use X bar and standard deviation. If it's not normal, we have to use our box plots and the 5-number summary. So knowing which one we're dealing with is a crucial piece of statistics. And most of the things that we're going to be doing, we want things to be normal distribution. So we've got this data set. So what you're going to do is you're going to put all that data into your calculators. So I've already put it in there. So if you want to stop the video, you can. I put all of it in there. One of the ways I did it, especially with data like this, is I just took my pencil and I covered it up, and I went down 3 this way, moved over, went down 3 this way. The reason I did that is there's multiple 15.6s and 16.6s, so it was easier to memorize 3 numbers as I went across. So that's how I did it. It's up to you. So I'd stop the video right now and then go from there. All right, so after you plug it in, there's 2 ways to look at it. So we go to stat plot, and I'm going to turn this one off, and I'm going to go back to plot 1, and I'm going to turn this one back on. And I'm just doing our standard histogram here, right? And when we look at this, I've got list 1, and then once we do that, we go to zoom 9. All right, so we've got our data, and we're looking at our data here, and we've got here, here, and we've got that, we got that, we got that, and then we have 2 small ones here. So we're looking at this, and it's like, close, not sure. This is bugging me right here. So they have something called the normality plot, or the normal probability plot, and it's in the calculator, and I'm going to show you how to do it. So what it does, just so you know, is it measures z-score. So it measures z-score 0, this one's a +1, this one's a +2, +3, -1, -2, -3, and then I'll kind of make a little more sense out of it here. So this is how we find that piece. So 2 ways to check for normality. 1, draw your histogram, double check that about 60%, 68% is in between the first 2 standard deviations, and that'll give you a rough idea. So you can use the empirical rule or the standard rule, normal distribution of the 68, 95, 99.7, or you can look at a normality plot, which is what we're going to do now, and it works better for small numbers. So this what we're doing now works for small data sets. The histogram and stuff works for a little bit larger data sets. So you can use either one. Let's look here. So I'm going to go to stat plot again. Oops. There we go. I'm going to go ahead and turn my first one off because I already have it set. And then I'm going to go back to plot 2 this time. You don't have to go in plot 2. So what we're looking for is this. When you're plotting normality, you make sure it's on. We're going all the way over to the very far right. There's this little graph here. It's a bunch of dots. Make sure the data is listed correctly. I have L1 listed. Data axis is the X. Doesn't matter. I can do different marks or whatever anything like that. So then we hit zoom 9. Zoom 9, and we get a graph that looks like that. So what this is saying is that we've got a few data points at -3, -2 z-scores away, and then if you look, it gets more and more data points in the middle, and then we have a few data points on the outside. So all I did really was redraw this. So what this tells us, if we look at it, if we look at this, what's this telling us is that most of the data points are right here in the middle. And if you look right here on this calculator, most of the data points are right in the middle. That's saying that the middle of the data is right at a 0 z-score, and most of the data is 1 z-score away. Then a little bit more is 2 z-scores away. And then a little bit more is 3 z-scores away, which makes sense because 68% or almost 70% of the data should be within 1 standard deviation. So this is a way to look at the fact that this data is normal because it follows a linear pattern. There's no like ideas of that it's out and messed up and out of the way of a linear pattern. So if it follows a linear pattern and you have most of your data right here, then you can assume that it's normal. So that's how you assume that it's approximately normal, is that it's linear and there's no clear like ideas to the left or right, or data points to the left or to the right. So when we're looking at data here, let's draw another one. And I've got a data normality plot that looks like this, and then I have right here. So I have a lot of data down here, and then it stretches. So if you look at this, remember this is 0, -1, -2, -3. If we're looking at this piece here, most of my data is down on the bottom, which means it's to the left because it's a negative z-score, and I'm stretching this to the right. So this would be a right skewed, because I have data that is to the right of my linear pattern, and most of my data is down here on the left for the z-score. So this would be a skewed right. So this one would not be normal. So if we go down to a strongly skewed left, that means that most of my data is going to be up here in a line, and then I'm going to tail way off. So it's going to be, I'm going to have very few over to the left, but they're going to be way out of the linear pattern. So if I drew my linear pattern here with this red line, that's the pattern it should follow if it was normal, and we should have equal amounts on either side of the 0 z-score, but I don't. I have all these over here, so that one is going to be skewed left because I'm pulling the mean to the left. So this one is skewed left. And that's how you would test for normality, using the normal graph. But remember, you can use a histogram, but you got to watch out because sometimes the histogram doesn't work for very small amounts of data. All right, we'll talk to you guys later.